Okay, these are the quick notes on linear relationships. All right, for all linear relationships, we know that they are either going to be proportional or non-proportional. The big differences that you're going to see in these relationships are that proportional relationships will go through the origin. They're going to be written as the equation y equals kx, so a number times x. They will have the same y-x ratio. So when you divide the values of y divided by the values of x in the table, that ratio will remain the same for all of the points on the line. You'll also realize that a proportional relationship has a constant of proportionality. That's the COP. So it should make sense. If it's proportional, it has a constant of proportionality. Over on the non-proportional side, you're going to see that there's no constant of proportionality. Well, it's not proportional. That should make sense. Opposite of a proportional relationship, it will have a different y over x ratio. It does not go through the origin. And the equation of the line is going to have that plus b at the end. Y equals mx plus b. So there's something extra added on at the end. One thing to remember is that because it's a linear relationship and it makes a line, they will both have a constant rate of change. And we're going to look at what that means. But when we're talking about lines, that means, is it getting steeper? Is it flattening out? Well, if it's a line, it should be the same steepness for the entire line. Okay, here's just another review of what we just talked about. In a proportional relationship, you're going to see here, if you find out what the constant of proportionality is, that's going to be the same as your constant rate of change. Over here, remember, there is no constant of proportionality, but we do have that constant rate of change because it's a line. It's not getting steeper, it's not getting flatter, okay? It still passes, you can see the line passes through the origin here. It does not pass through the origin here. This line could extend beyond as well, as could this one, okay? And our equation is y equals kx, and there's that y equals mx plus b on this side. So that's what it looks like. So what is this constant of proportionality? Well, here's the equation that we were told matches with a proportional relationship, y equals kx. Well, the constant of proportionality is that k, that coefficient, that number before the x. So if we're not given an equation, but instead we're given a table, we're going to find the constant of proportionality by finding the y over x ratio. And when we do this, we can ignore this 0, 0. 0 divided by 0 is 0. But when we find our constant of proportionality, we're actually not going to use the 0 to do that. We're going to look at all of the other compared ratios. So we're going to take, remember, this is my x, this is my y. So it says y over x ratio. So I'm going to put 6 over 2. That's the same as 6 divided by 2, which equals 3. Here I've got 12 and 4. So 12 is my y. 12 divided by 4 is equal to 3. 18 over 6, which also equals 3. Now, as we compare our y over x ratios, you can see they were all 3. So is it proportional? Yes, it is. And how do we know? Because our y over x ratio is constant. Okay? So that's what we're looking for to know if this is proportional or not. And as we saw in the previous slide, if it's proportional, our COP, constant of proportionality, will also equal our constant rate of change. Okay? Let's look at the next example. We're going to find the constant of proportionality here, if it exists. So we're going to look at that y over x ratio. 4 over 0 is equal to 0. 10 over 2 is equal to 5. Again, this is my x and this is my y. I'm simply comparing my y over x ratio. I'm taking the number here and putting it on top of this number here. 16 over 4, which is 4. 22 over 6, which is equal to 3.6, repeating. Okay, now as we look to see, is this a proportional relationship? I'm comparing the numbers here. Are they the same? Is there a constant ratio? There is not. So this is not a proportional relationship because the y over x ratio is not constant. And we know that there is no constant of proportionality in that case, okay? There is no constant of proportionality because our ratios are not the same, okay? This last question here asks, what's the clue from the table that tells us this is not proportional? Well, because it's given us a 0 in our table, we can see that the other value is a 4. And if it was proportional, it would have been 0, 0. Okay, so this is, if we use our table, we can look right here. This is not going to be proportional because we don't go through the origin. Okay, this is just a quick example to show you that just because it does go through the origin, okay, so this graph is going through the origin, but it is not linear, does not make a line. Okay, this is a curved line versus a straight line. And it's not proportional because it does not have a constant rate of change. What that means is it staying the same steepness the whole length of the line? No, this is getting steeper and then flatter and then steeper again. So this has no constant rate of change. It's not proportional and it is non-linear. Okay, so I just wanted to show you that just because it goes through the origin does not mean it's going to be proportional. All right, we're going to move on to find the constant rate of change. So in that, when we see that word change, that's going to clue us in that there's a difference. Okay, we are going to be finding the difference between values. So the constant rate of change can be defined as the change in y over the change in x. There's some other names that it goes by. It goes by the name slope. It can go by the terms rise over run. And it can also go by that coefficient m, or that variable m. And you might also hear it be called the difference in y over the difference in x. Okay, so there's a lot of different names for the constant rate of change, and obviously we abbreviate with CROC, okay? But it is the ratio of the difference in y over the difference in x, or the change in y over the change in x. So let's look at how we find that. If we're looking for the constant rate of change with this first example, we're going to find the difference between these numbers. Well, we're adding 2 to get here. Okay, so what I'm doing is I'm saying 0 plus 2 equals 2. 2 plus 2 equals 4. 4 plus 2 equals 6. And 6 plus 4 equals 10. Again, this is my x. This is my y. Okay, 0 plus 6 equals 6. 6 plus 6 equals 12. And 12 plus 6 equals 18. 18 plus 12 equals 30. So I'm finding what the difference is between the two numbers that I'm pointing my arrows at here. Okay, now one thing to make sure of is it does not matter that these numbers in this column are not the same. Okay, that's not what we're looking for. What we're looking for is the ratio of how they change. We want that to be the same. So you're going to pick any row that you want. So if you choose this first row here, you remember it's the difference in y. Okay, this is the difference in y right here. This is the difference in x. Okay, so if this is the difference in y on this row, we're going to put the difference in y over the difference in x. So in this case, it would be 6 right here, and the difference in x was that 2. 6 over 2 would equal 3, okay? If you decided you wanted to use this last row to find your change, your constant rate of change, you would use the 12, the difference in y, divided by the 4, okay? And that would also give you 3. You should check a couple points just to make sure that it's a constant rate of change, that we're getting the same answer every time. But in this case, the constant rate of change would be 3. The difference in y over the difference in x. Okay, let's look at one more example here. What is the constant rate of change for this problem? I'm going to do this quickly. We're just finding the difference between the two numbers. That's another 12. And here we've got 2, 2. These are the same tables from the beginning. It's just asking, this time we're finding the constant rate of change versus the constant of proportionality. So here, again, we're finding the difference in y. So here's, if I use this row here to start with, the difference in y is here, 6 over 2 is 3. And I use this example, it looks the same, but remember our previous problem, if you go back a slide, this was a proportional relationship, whereas this one here is not proportional. Remember, we just solved for that in a couple slides ago, but we also see it's got 0, 4 there. Something to keep in mind is it does not have to have 0 in the table, okay? There are 1,000 points on every line, infinite points on every line. So if you think about a line, okay, there are infinite points on this line. And the table is only picking a couple of the points on this line to show you. They may not tell you what 0 is. There's no rule that says they have to tell you what 0 is. So don't assume that because there's no 0, 0 in the table that it is not proportional. They may not have just put 0 in the table, okay? One other quick thing I wanted to tell you, if you go back to where we found the constant of proportionality, they're not going to have this y over x ratio there for you. I put that there to show you with notes how to do that. Most of the time, okay, sorry for that interruption. So if you get, most of the time you're going to get a table that looks a lot like this. And if you're asked to find the constant of proportionality, you would need to put in that column or right off to the side to be able to find your constant of proportionality, that y over x ratio, okay? So they're not going to put that y over x column there for you. I did that so that I could demonstrate in the notes, but you will need to put that in yourself to find the constant of proportionality, okay? This slide, we were actually finding the constant rate of change, which we did, and once again, 6 over 2 was 3. And if you decided to use any other number or row, you would get the same answer also. Once again, we see 12 divided by 4 would also give us that 3, okay? Real quickly, if you have to find the constant rate of change from a graph, you are going to use that rise over run that we talked about. Rise tells us how much are we going up, and run tells us how much are we going over. So you select any 2 points on your graph that you'd like to look at, and you're going to count how many am I going up. So I'm going to go up 1, 2 units, or 2 lines, and check that it truly is 2 units. So I'm counting by ones on this side of the graph, on this axis, so that I am rising 2. And then you're going to count over, or run is the over, how many do you have to count to get to the next, to that dot. So this is 0.1 and this is 0.2. I'm going to count 1, 2, 3, 4 units over. But if you look down here, each unit is actually worth 3 pounds. So 4 times 3 is 12. So I'm actually, from 6 to 18, I actually moved 12 units. Okay? So when I simplify that, that would be 1/6. And so that would be my constant rate of change and how I would determine that from a graph. Okay, that's it for the notes for now.